for the other students. And I'm going also to share my screen. Just a moment. Okay, this is it. Just tell me that you are seeing this okay, and you are hearing me well. So I am Tom Savu. I am a professor in the Polytechnica University in Bucharest. I'm teaching computer programming and image processing. And in the fourth module of this project, module which is called we will discuss about in this module, we will discuss about advanced communication tools and techniques. Is basically, maybe you saw on the content on the Moodle platform, is basically about communication using computers, so computer tools. And we will have four parts. Today, we are going to discuss a little bit about augmented reality, tomorrow about virtual reality, and Monday next week, we will have two sessions. First, about virtual museums, and second, about holography and geolocation. So I hope I will see, but please, if you like to ask questions during my presentation, you can interrupt me anytime, either by raising your hand or just open your microphone and ask the question. This would be the content of the presentation for today about augmented reality. And we are going to start with a short definition, an introduction to AR. I will say AR instead of augmented reality from now on. So a definition would be, if you are looking to this picture on the right, that AR overlays digital information, which can be pictures, movies, 3D models, and so on, onto the real world in real time. So you see, for example, one person is using the phone, looking to this stuff, and is seeing overlaid on the real-time image, is seeing labels with the description and price and so on. So from this, it's clear that AR is increasing the quantity of information which we are receiving when looking to certain objects or to landscapes, scenes, buildings, and so on. It's integrated these computer-generated elements, and of course, this is leading to an enhancement in the user's perception and interaction with the real world. What I would like to do is to underline the differences between these three tools: augmented reality, virtual reality, and mixed reality. So in augmented reality, as I said before, we are seeing first the real image from the real world, and on this image from the real world, we are seeing some computer-generated objects, which could be, for example, these labels. In virtual reality, all we are seeing is a computer-generated image. So one case of virtual reality is when we are using these glasses. So it's obvious that using these virtual reality glasses, we can see only the image that the computer is sending to us on the screen, on the glasses. And this image is completely generated by a computer. In the mixed reality, we are seeing, as the name says, a combination of these two, with the difference that the part you see, for example, here, where the image is pretty small, here we are seeing the real environment, so the room, the real table, and so on. And on the real table, we are seeing a 3D model of a building. So, presuming these persons are architects. So, here, the image generated by the computer has no relation with the image we are seeing from the real life. So we see from the real life the table, and the computer is generating for us here a building, but it can also generate a flower, it can generate a dinosaur, and so on. So it's not generating something related to the table, for example. So these are different, the differences. So we will talk today and tomorrow about augmented and virtual reality. We are not going to talk about mixed reality, but they are completely different things. Also, when talking about augmented reality, which means that we see some objects superimposed on the real picture, we don't have to, for example, make the confusion with what we are seeing, for example, on TV when we are viewing the news, and in the bottom part of the screen we are seeing some texts and so on. This is not augmented reality, because in augmented reality, the objects generated by the computer are moving when we are moving the phone or the tablet, for example. So the objects generated by the computer are linked automatically to the real objects from the real life. Maybe we will come back to these differences. Let's talk about a little bit about the history of AR. It is considered that the first step was done in 1968 by Sutherland. He was named the father of augmented reality, who developed this device on which, on small screens, he can, and they were transparent screens, he was able to project simple images which were superimposed on the real image the user was seeing through the transparent lens. It is something, let's say, similar to the situation when we are looking through a binocular, And on the image, we are seeing some reticular wires, green wires, which are superimposed. Of course, in this device of Sutherland, the objects generated by, it wasn't a computer at that time, it was a video system. The objects generated by the video systems were more dynamic. But of course, as you can see, the device was pretty heavy. Then in 1974, it was developed not a device, but a whole laboratory called the video place. So the user was able to, using also some glasses, the user was able to see an image like this. He was seeing a silhouette of himself, and he was seeing a virtual image. And the lab contains also video cameras, for example, which were tracking his movement, and the user was able to interact with this virtual image. So was able, for example, to choose letter and build some words and some phrases. It's looking very simple today, but for 1967, 77, sorry, when the computers were in their beginning, it was quite an achievement. Then, only in 1992 at Boeing, they developed a system which allows a worker to receive information about the tasks he has to perform. So, for example, this worker was putting in place some wires, and on the glasses, he was seeing data about which is the position where he has to put the wires correctly. And in 1993, sorry, this system Karma incorporated knowledge-based. What means knowledge-based? For example, you see the user is pulling out a part from this equipment. Well, Karma knows which were the dimensions of this part the user is pulling out, and is representing all the dimensions of the part, so the user was able to know how long this part is and how more does he has to pull the part out. In 1993, also Fitzmaurice developed the first handheld display. So it was, for the first time, it was like a tablet. It was maybe the first tablet developed, and he was able also, the tablet was aware about its position in space. So if he was moving the tablet, the image on the tablet, on the display, was also moving. It was also a pretty heavy tablet. The technology was not so well developed. A very spectacular application in 1994 is this one, where a physician was able to observe the image of a fetus directly on the pregnant patient. So basically the computer was taking the image of the fetus from the medical equipment. I forgot the name, and was displaying the image above the image of the patient in the exact position. So the position of the computer generated image was dynamic. So it was displaying the image in the exact position. So the doctor was able to appreciate if the fetus is staying there in the correct position. It was a pretty revolutionary uh, application for that time, 30 years ago. In 1995, Steve Mann developed this application in which you can see the glasses were pretty smaller than the devices before. He had also some other sensors, but these are not related. All the sensors you are seeing on his head are not related with the augmented reality application. And he was able, it was something like a Google Maps application from today. So the glasses were also measuring the position and the direction to which he is going. And the system, the augmented reality system, was able to put on the image texts indicating him the direction in which he has to go. Then, in 1995, this system, Navicam, it was really the first handheld display. So it was not like a big heavy tablet. It was able to be kept in one hand. It has its own camera. So it was something like a more developed smartphone from today. And in 1996, it was developed a system for multiple users. So you see the system, it was basically developed for education, for geometry, let's say. So the system was able to generate this image with a sphere and all kind of geometric forms here. And different users were seeing this image from different points of view, like they are looking to a real object from different positions. More than that, the different users were able to interact with the virtual objects. For example, they were able to write notes somewhere in space, and the notes one person was writing were able to be seen also by the other persons. In 1997, already the multiple users augmented reality games started to be developed, but you see this is more than a mixed reality, not only augmented reality. And in 1997, Feiner developed the first system which was able to be used outdoor. It was also pretty heavy, pretty complicated, but it was able to be used outdoor, and it was able, if the user was looking to a building, it was able to display some information to recognize the building and to display some information about it. This platform is also a multiple user game, but is also made for outdoor environment. So it does not need computers which are staying in a building. It was based only on the computers the users are carrying with it. Also a multiple user application if this office developed in 1998, and in 1999 it was developed the first open source software platform. Open source means the software is distributed to the public, and the public is able to change the software and to adapt the software to their needs, let's say. And in 2003, the equipment started to look like today's smartphones, and so on. Talking about how augmented reality works, it's pretty simple after we saw all these examples. So basically the device, which can be a phone or augmented reality glasses or a tablet, is taking the image, is analyzing the image, and is identifying the objects in the image, is sending the information about the objects to a database, and from the database is taking the data about the objects. After is taking the data about the object, like this one, is putting the data, which can be text or another image, is putting the supplementary data on top, the computer-generated supplementary data, on top of the real image the user is seeing. So from this point of view, it's, let's say, it's pretty simple. Let's see some today applications. For example, in repairing cars or different equipment, when looking to different parts of the engine, an augmented reality system can tell to the worker which are the next operations, which are the activities to be done to repair the engine. Or when looking to some buildings, the system can display information about points of interests, or can display data about the buildings, or data about the places, let's say. Another application is the real-time translation, in which we are seeing, and this is already available on the today phones. Maybe we all have it on our smartphones, and we are using it when translating the menus from the restaurant, for example. Navigation, of course, the parking assistant. It's an augmented reality application, which is displaying this computer-generated data on the real image we are seeing through the rear camera of our car. When we are looking to soccer game, to football game, or to other sports, from time to time we are seeing all kinds of lines which are computer generated and which are moving when the players are moving. This is also augmented reality. We have applications in the supermarket on which when pointing our phone to some products, we are seeing additional data about the products we are looking to. And there are, for example, these kind of applications. I will start the YouTube. Just tell me if you are hearing the music from the video. Okay, probably yes. So this is an application maybe you saw either on a tablet or either in different shops on a sort of magic mirrors, where we can see how the clothes are looking on our body. There is also another application from IKEA in which is advertising, sorry. So maybe you know the IKEA application in which we are looking with our phone to our camera, and we can test different pieces of furniture from IKEA to see how they will look like in the camera, and to decide about the position, for example, or about the most suitable color, and so on. Similar applications are not for furniture, but for Rolex watches. But here you see we need to stick a little marker on our hand, and using this marker, the application is finding out where to place the image of the watch. A similar application is this one for glasses. A similar application is this one for shoes, where we can try different types and color of shoes, just to see how they will look on our feet, and so on. I will be maybe pretty short about the software used for developing augmented reality applications. I will not enter in the details, but just to know the names of the software applications which are mostly used for developing augmented reality is this Reality Max. It's Unity, which is very well known by the software developers, and Eco 3D also, and Spark AR. But talking generally about software for developing augmented reality application, but there are a lot of software tools. What is maybe more important to know is that there are different categories. The first category is this development software. The development software, we can imagine, is the software used by a programmer. So the programmer, the developer, is doing almost everything in this software. Then we have the content management systems. The content management systems are like some like a file explorer in Windows. They are helping us to keep organized the pictures, the databases, the videos, and so on. And there is also another category which are the collaboration tools. Because when an augmented reality application become too complex, it's not possible to be developed by a single programmer, and it has to be developed by a team, which means several programmers are working in the same times, and their results have to be synchronized, and these collaboration tools are doing just this. And there is also a fourth category, which are the game engines. These are, let's say, the most complex because they are specialized on game development, and for that, the operations they have to perform are more complex than for, let's say, normal augmented realities applications. Let's see which would be the challenges for augmented reality. The first one are the technical limitations, because for developing an augmented reality application, we need a lot of processing power. We need also high resolution cameras. We need sensors which are sensing where the user is moving, or the phone is moving, or the tablet is moving, and so on. Of course, we want to generate images with higher and higher quality, higher and higher resolutions. So basically, all the time, these hardware resources needs to be developed, like it's happening in the computers field with the processors, the phones, the cameras, and so on. Augmented reality is not very interactive compared to virtual reality. So, because the user is seeing mainly the image from the real world, and all he can do is to move the phone and the camera, and the labels will move on the image. In augmented reality, the image generated by the computer does not depend very much on the actions of the user, apart from the movement, from the position. But the user cannot change the image, cannot change the shape of the object generated by the computer. So the interactivity is more limited than in virtual reality, for example. Because because the applications are developed not for high performance computers, but for phones, tablets, and so on. The graphics and the audio are not at the highest quality. Also, when processing 3D images and having to process these images in real time, it can happen that the applications are making mistakes in the order they are displaying the objects in the picture. So these are known as occlusion issues. Of course, there are the problems about privacy and security, because the image or the actions of the users can be recorded. Of course, the hardware, like the augmented reality glasses, is pretty expensive. It can be, for example, several thousands dollars. When we have multiple objects in the image, it may become difficult for the system to identify, separate each object and to track its movement. There are still issues with the voice recognition and processing. So if we are not speaking loud and clear, it may happen that the system does not understand very well what we are saying. It needs a lot of internet traffic, so the applications may not work very well if we don't have a pretty good internet connection. And it's pretty costly, it's pretty expensive to develop a complex application, because not only for the hardware involved, but basically for the cost of programming. And last but not least, because we have a few main big companies like Apple and Google, there are compatibility issues. So not all the applications developed on the Google system are working on Apple. Not all the developers are developing in the same time their applications, both for Google and Apple and so on. And if it is about thinking to develop this kind of applications for an organization, is pretty difficult to estimate how much it will be the return on investment, because it's difficult to estimate which would be the impact of using these applications with our public. For example, if we are in a museum, or with our students if we are in a school. I'm not going to insist, because I knew the time was pretty short. For example, discussing only about the future of augmented reality. Back. I only included for you here in the presentation some links on YouTube. They are short videos, so this is an advertising. I'm encouraging you to look to these videos. They are 1 to 3 minutes, let's say, but I'm not going to play all these videos now. For example, one future application in this video, I want to go to relevant, okay, here it is. You see, instead of looking to the normal weather app we all have on our phone, we can have an augmented reality app which will show us how the sky will look like if the weather estimation is that is going to rain. It will show us the rain and so on. So these are applications which most probably will appear in the near future. I'm not going to move to the next movies. I just want to show you one piece of product which appeared a few days ago. Is this Space-Talk G1, it is called. Is basically, you will see it immediately, you see here, is basically a laptop without a screen. And instead of the screen, it has a pair of AR glasses. And when I'm wearing the glasses, I can see the different windows. Normally, I am seeing on the screen of the laptop. So this is already, maybe it was mentioned in one of the videos about the future of AR, but it was launched, it was shown a few days ago, and I think is going to be launched this month in Japan and Hong Kong, something like this, and in July in the States and Europe. And if it's going to work as we can see here, it will be maybe very useful because we will be able to see, you saw, we will be able to see more windows in the same time, and we are needing less, less space for the laptop. Of course, it's going to be a little bit expensive. If I remember correctly, it will be around 2,500 euros, but probably in the next year it will become, let's say, a common piece of equipment. So, approaching to the end, so these are the references for my presentation, and let's hear if there are any questions till now. I know it was, so the time was pretty short. I tried to present a lot of information. Let's hear if there are any questions from your part. If not, here on the Moodle platform, for the moment, you were able, I think the colors here are not very good. So here, after this, the title of this session, Augmented Reality, you are able to see the link to this Zoom meeting. After the link, after the recording will be ready, I will upload here on the platform a link to the recording, especially for the people who was not able to attend and would like to have a look. And after this, I inserted on the platform a discussion forum. If you will enter on this discussion forum, you will be able to add new topics. And when new topics will be added, you will be able to ask questions in those topics, like a normal discussion topic. So I will create the first topic, and in this forum, I will call it feedback. And I am writing here, please write here your opinions about this session about augmented reality. Okay, so the first thing I would like to ask you would be to give me a feedback and to say, you know, if the presentation was clear, if the information was enough, if there are some topics which remained not discussed and so on, or you can create other topics and ask your questions here. If you will have some questions after this presentation. So no questions for the moment. Okay, so the last part would be a hands-on activity. So I would like you to use an application which is called Artivive, and to create a small augmented reality product. You have a tutorial here, so you will have I will also upload the presentation, not only the recording. So you will be able to go to this tutorial. Yes. Watch the tutorial and then go to the Artivive application. You can sign in for a free account, and you can sign in with a Google account or with your Facebook account. And after you sign in, you will see the collection of your applications. Of course, in the beginning, you will have no applications here. And basically, to develop one application, you will have to upload an image and a movie. And I uploaded this image. This image is the passport of my cat. In his passport, the vet is writing all kind of things, probably you know. So I uploaded this image of his passport, and I uploaded also this video of my cat. Okay? And Artivive made this application in which, and I have to upload on my phone from Play Store or from Apple Store an app which is called Artivive. You will see it maybe here in the tutorial. If I have the application installed on my phone and I'm starting the application and I'm pointing the camera of my phone to the passport, I will see, like here in this image, I will see the movie on top of the passport. But I will see this on my phone with the Artivive application. So I created for free my first augmented reality application. Basically, I have to upload the image of the object I want to be recognized by the application, and then I have to upload the movie which I want to be displayed on top of the static image. If I upload these two, they are uploaded on the net in the Artivive database. And when I open the Artivive application on my phone, and the application is recognizing this image, is taking the movie from the database and is movie on top of this. Well, after you are doing this, so you are creating your account, you are preparing the image and the video, you create your art according to the tutorial. Basically, after you upload the image and the video, you are just pressing a button, create. Then you install the Artivive application and you watch the results using your phone. After you are doing this, I will ask you to upload. So you see here on the Moodle page of our course, we have an assignment, which is called AR App. So I would like to ask you to upload here a short text which describes your application and upload the static image to be scanned in Activive for accessing your augmented reality application. So if you are uploading here, you will see a button, Add Submission. And if you click on this button, Add Submission, you can write here the description of your application, and you can upload here the image. After you upload the image, I will display your image on the screen, and I will look to your image with my Activate app from my phone, and I will have to see the video you uploaded on Activate application. So this is what you have to do as an assignment for successfully completing the first part of this session, the part of about augmented reality. If you will have some difficulties in performing this hands-on part of our course, please feel free to send me an email. I think you can see my email here in the list of participants somewhere, or you can post your question in the forum. I will create in the forum, apart from the feedback, I will create a separate discussion topic called hands-on app. Right here, questions. If you had difficulties in building your first AR application. And if you, it's better to write in the forum than sending emails, because if you write in the forum, the problems and the answers can be seen by all participants, and in this way we are learning a little bit more. So once again, just to recap, just after this session, I will upload here the presentation. When Zoom will finish processing the recording, I will upload a link to the recording to be able to see the recording later. Please feel free to ask any questions about augmented reality. Please leave me a feedback about my presentation, and then do your assignment, upload the results here, and if you have problems in finishing your assignment, ask questions on the forum. And this would be all about augmented reality for now. Finally, if you have any questions or final thoughts for today, please tell me. If not, thanks again. Yes, please.
I have a question. How long do we have to upload this task?
It's up to you. I don't know, because it's, to be sincere, it's not very clear in the project how the course will finish, you know. I think you are going to receive some participating certificates. It would be normal. I'm not sure, because I'm not the organizer of this experimental course. So I'm only a teacher, you know. So basically, it's not compulsory. But if you are interested in the topic, why not to try, you know? So it's better to try, because it's not very complicated. I think if you have the picture and the video, and it has to be something very simple, I think it's not taking you more than, I don't know, 20 minutes, half an hour, you know?
Thank you.
But I wanted, and you will have hands-on experiences in all of these 4 modules, because I thought maybe it's more interactive, and for the participants who wants also to learn a little bit more, to go deeper, let's say, maybe it's useful. But I don't have a timeline, to be sincere, you know. Okay, thank you very much for your question. Any other questions?
Yes. Hello.
Hello.
I have a question. We need just a picture to associate to the video.
Yes.
Just one picture.
One picture and one video. And basically, when we start the application, when we start the RT5 app on the phone, and the RT5 app is opening the phone camera, when we look with the camera to the object, on top of the object, like here, so imagine this is my phone, and I open the application, and I'm moving the phone to see the image, and then the application is taking the movie automatically from the internet. You know, so it's something very simple, but just to be able to say, look, I did an augmented reality application. It can be, for example, with a book, you know, an application would be, for example, if you have a book after which a movie was made, you know, and when you point your phone to the book, you can see a scene from the movie, for example. Or, for example, let's say you had a very nice party, and people was staying on the sofa, you know, they left. but you took some movies during the party. So in the app, when you will look to the sofa, you will see the people dancing during the party. So there can be all kind of ideas, you know. Or
Okay.
if you look to a static picture of someone and you have a movie with that person talking, if you look to the image, you will see the movie with the person talking and so on. So there are a lot of ideas. This is Artivive. It's a very simple application. So the free, you see the free account allows the application to be run only 50 times. So it's very simple and it's free. It's not complex at all, but it is a first experience in augmented reality. Okay?
Okay, thank you.
Thank you. Any other questions? Okay, if not, thank you again for your participation. I will stop the sharing, and I will also stop the recording. And thanks a lot again, and see you tomorrow at the same hour. Have a nice evening.